Now, as we saw last time, a key element about having classes is that we can build hierarchies, that is, classes that inherit from other classes. It gives us a very crisp way of building code that can be reused. It lets us build modules that easily interrelate. So let's look at that idea here. I've got the idea of a person. Now I'm going to add a new kind of person, an MIT person. Contrary to popular belief, MIT people are people. They have the same properties. They're born. They have a name. We'll add a few other things, though, to an MIT person. They have an ID number. And one of the things we want to look at is how we can use the ID number to identify specific instances and use that, in fact, for things like sorting. So let's look at how we might build an MIT person. So here's my class definition. And I want to show you a couple of highlights here, things that are important. The first one is, as I did in an earlier example, I'm going to create a class attribute. So this is a definition of a data object that's built into the class. Does not belong to an instance, it belongs to the class. And it's going to let me keep track of how many ID numbers have I assigned. I'll initialize it to 0. That's a good place to start. Even though MIT person is a kind of person, I'm going to build an initializer, something that creates instances for this class as well. But the interesting thing here is I'm going to use the underlying person method to also create the instance. So when I call MIT person, it's going to create an instance, but it's going to call the person class initialization method to initialize the same kinds of things, the name, and as a consequence, it'll set up a birth date in case I want to use that. Second thing I'm going to do, though, is assign to this instance an ID number. So self here will say that I'm going to, in this instance, bind ID num to a particular value, but I'm going to use the value associated with MIT person. I do MIT person dot next ID num. It will get the value of that data variable and assign it to this instance. And then finally, I'm going to increment that global class data attribute by 1, so that the next person I create is going to have the next number in the sequence. Once I've done that, I could get out the ID number of a person. And sorting here, I'm going to do simply by comparing ID numbers. If I want to sort a list of MIT people, I'll do them by ID number, starting at 0 and moving up. The last one we'll come back to later on is I'm going to give MIT people the ability to speak. I'll give them a string that I want them to say, and they'll return something that says their last name, says, and then a string. We'll look at an example of that in a second. With that in mind, let's look at what would happen if I built some examples of this. So a way to think about this is, in my memory somewhere, I have a representation for the person class, and I have a representation for the MIT person class. When I call for an instance of MIT person, it's going to use this init procedure because it's that class, and that's the one that's visible inside this environment. But as we saw in the code, calling that init procedure then calls the person init procedure. It literally goes into the person class definition and finds that init procedure and calls it. And that will set up a binding for name and date birth date rather, inside of that instance. In particular, that is returned to the MIT person class because that's the place where the call was done. But the bindings come from the init procedure that's associated with person. So I've just created that instance, and having done that, and that'll have a binding, for example, to a last name, the next thing I do is I get the value of the ID number from next ID num inside of MIT person, and I bind that to the ID number for this instance. Great, this is now person number 0. And that's because of this call right here, which says within that self, bind ID num to what we see inside the class definition. And then the next thing I do is I update next ID num by 1 inside that MIT person environment. That's great, because now I have an instance with an ID number associated with it. And if I were to call for another instance of MIT person, it will go through the same process, calling the person init method to set it up. But now, next ID num is 1. So the binding here is ID number 1, and that gets incremented to 2. You see as a consequence how that class attribute can store information I can use to associate with instances of the class. Great. Now what happens if we create it? Well, again, I'm going to take a similar set of characters. I'm now going to make them MIT people. I'm going to create a Mark Zuckerberg, a Drew Houston, and a Bill Gates. I'm going to give them birthdays. And I'm going to, you may notice here, even though I'm going to create them in this order, I'm going to change the numbering so that M3, although it's the first one I created, I'm going to have the third element in my list down here as I build it. And let's see what happens if I were to go and do that for this particular example. Let me just set up my computer. And if I call that, I now have a set of people in my system. And let me just look at an example. If I print out M1, I get Bill Gates. That's great. That's what I called him down there. If I print out M3, I get Mark Zuckerberg. And one of the things I said is I could have these people say something. So I could print M3 speak, and I'll just have him say something pretty straightforward like, hi there. And it prints out, as I expected, Gates says, hi there. Okay. One of the reasons I wanted ID numbers was so that I could do things like sort people. I'm going to use them in other ways to access information. But let's look at now going back to the same kind of example. What would happen if I were to print out the people in this list? Well, if I just do that, I'm going to see what you would expect to happen. I'm going to now load this up and print it. And it prints out as shown on the screen here, Bill Gates, Drew Houston, Mark Zuckerberg. Now remember, I created them in a particular order. This is the order I created them in. So in fact, that's the way in which it prints them out. Even though in the list, they were in a different order. Now, let's look what happens if I do them by ID number. And if I were to go ahead and sort, and then recall this, now it prints them out by ID number. Zuckerberg first, then Houston, then Gates. So you can see in this case, I am sorting by ID, exactly as I set it up. Great. What else might we do with this? Well, let me create another version of a little set of MIT people, partly to show you that the ID number can be important because the names may not be distinctive. So here I've created 3 MIT people, Eric and 2 Johns. I've also created just a base person, also with the name John. And I want to think about things like, how might I sort these? Well, in particular, what happens? Well, first of all, what happens when I create them? In this case, I have bindings for P1, P2, and P3, 2 instances of MIT people, each with a unique ID number. P4 points to a different kind of object. It's just a person, no ID number associated with them. It's going to be important in a second. And now let's look what happens if we wanted to do things like compare them, which would be part of doing the sort. So I'm going to try some examples here. Having loaded those into my system, let's ask, is P1 less than P2? And it says true. Okay? That makes sense because the sorting here should be done on the basis of ID number. I created P1 before I created P2. Great. Now let me ask, is P1 less than P4? Oh goodness, I get an attribute error. Let's try it the other way. Is P4 less than P1? No. Wait a minute. What's going on here? Well, this is highlighting how a class or an instance of a class gets a method. So why is it that in one case it works and in another case it doesn't? So how's the comparison actually taking place? What happens is that MIT person as a class has its own less than method. And that method shadows the person method, meaning if we compare an MIT person object, since its environment inherits from that person class environment, it will see this version of less than. It won't see the person version of it. As a consequence, when we ask is P1 less than P2, that is literally converted into this form here. It says P1 dot less than of P2. Long string. It basically says from the P1 object, get the less than method. I just said because it's an MIT person, it will get that version of the method. And then it's going to apply it to self, which is P1 and P2. And it will do the appropriate comparison because these are 2 MIT people objects. It's going to use the less than method appropriately on that, comparing ID numbers. On the other hand, why does P4 less than P1 work, but P1 less than P4 does not? P4 less than P1 is equivalent to asking P4 dot less than method applied to P1, which means we use the less than method associated with the type of P4, which in this case is a person, one that compares based on name. So based on name, it can come up with an answer, which is great. On the other hand, when we ask P1 less than P4, that's equivalent to getting the less than method associated with the type of P1, which is an MIT person. And since that tries to compare on ID numbers, and P4 as a person does not have an ID number, this will throw an error, or in this case, say that there's an attribute error. I don't have an ID number associated with it. So we see that the less than method, we have to be careful to make sure we use the appropriate one for the kinds of objects we want to use. And in particular, the specific object calling it, in this case, the first one in that comparison, is the one that's going to define the type and therefore the method that we want to use.